Okay. So, in the last class we considered the graphical approach to circular convolution. There was a very quick recap. There are two sequences to be x n and h n, both are length capital N, and this was the expression for circular convolution. How to carry out it graphically? I said keep one signal as it is, length n, that is x, write it as a function of r. Keep another signal also as a function of r, but then make it periodic, that is whatever you have from 0 to n minus 1, just keep repeating it. So, h of 0 at 0th point, again at capital Nth point it comes at, then at 2nth point also h 0 will come, so on and so forth. So, this whole block keeps repeating. So, you make a periodic version of that. Next step is flip it. The right side goes to left hand side goes to right hand side. Rth point goes to minus rth goes to rth. After flipping it, now if you want to carry out this convolution, circular convolution at an index n, okay, you want to find out y n at an n in this range, then you shift this flipped periodic sequence to the right by small n. After that, you hold this as it is and multiply term by term with this original sequence. And now original sequence is 0 outside this window, that is outside 0 to capital N minus 1 zone, it is 0. So, no point in considering anything outside that window from this flipped sequence. So, it will be sample wise multiplication, and we see x 0 into h 0 here already present, x 0 h 0. Then here x 0 h 0, x 1 I mean, okay. To start from this side, if you shift it to n, okay, shift, then h 0 comes here, h 1 here dot dot dot. So, at nth position h 0, n minus 1 h 1. So, 0 h, that is n minus nth, and now if you multiply h 0 into x n, it is present, h 1 into x n minus 1 present, dot dot dot, h n into x 0 present. There is a linear convolution part we have seen, and that additional term also you get h capital N minus 1, because this is periodic. If h 0, then the next period is a trail of the next period. So, h capital N minus 1, that comes at small n plus 1 with index, that multiplies x n plus 1 you get here, and we verify it. Okay. But as I told you, this convolution expression is not linear convolution between x and h, it is a summation of 2. Okay. This part linear convolution plus an extra term. That is why from this y n, which is equal to this, I cannot extract the linear convolution part as it is. Then the question is, if I want to still carry out linear convolution by this means, what do I do? Now, that can be done, but before that you understand, when I convolve two sequences, suppose I am convolving two sequences, one is x, say x r, there is x 0, x 1 dot 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 dot, x n minus 1 and then zeros, and there is another sequence, say h r, h 0, h 1, h 2 dot 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 this. When you convolve, you have to flip this one. So, suppose you flip it. So, you have got h 0, h 1, h 2 dot dot dot. So, at minus 1 this, minus 2 this, at minus n minus 1, you have got h n minus 1. Now, without any shift, you have got only these two terms multiplying, you get some value. So, some value you get. Then if you shift this to the left, then there is no overlap, you do not get anything. That means, output for shift 1, shift 2, is 0. But that is I am finding out convolution at various values of n. Okay. This was for n equal to 0, no shift. Remember, so for now n equal to minus 1, this should be shifted to the left by 1 bit. If I do that and then multiply term wise, sample wise between the two, there is no overlap between this and this, no overlap. Okay. So, 0. If I shift it further to the left and then again multiply sample wise between these two, 0. So, for n minus 1, minus 2, minus 3, this is 0. If you, on the other hand, if I shift it to the right, h 0 comes below x 1, h 1 comes below x 0. So, two samples multiply, x 0 with h 1, x 1 with h 0, you get some value, and you continue doing it. This h 0 after some time will come here. I am keeping shifting. How long will you get non-zero value? That is what we are seeing. So, this h 0 is moving as you keep shifting it to the right by 1, n equal to 1, then 2, there is n equal to 2, dot dot dot. Finally, a stage will come when H 0, there is a leader in this train, he has come here, so that the last guy H n minus 1 is here, okay, and so these two multiply. After that, if I shift it further, again there is no overlap, okay, samples from here multiply 0 from here, samples from here multiply 0 from there, and you continue to get 0. So, after how many, so H 0 was here, after how many shift H 0 will come here, so that H capital N minus 1 moves to this, okay, that is the question. So, obviously, n minus 1, after one shift comes here, two shift comes here, after n minus 1 shift it comes to 0, and then another n minus 1 shift it comes here. So, 2 into n minus 1. Okay. So, if it is, if this sequence is shifted to the right by 2 into n minus 1, this will come first here and then here. Okay. So, n equal to up to this, there is this index from 0, if we consider now H 0, this is also shifted by the same amount. So, this will be 2 n minus 1 minus 1, okay, because it is 1, 2 like that, all right. All right. Anyway, this calculation I have to recheck. So, you get like this. Okay. In general, let us consider a more, actually I cut it because I want to go to a more general case. Earlier I took both the sequences to be of the same length. So, that is what I wanted to change, that is why I cut that. Okay. X r, suppose it is as it is up to n minus 1. So, length n and H r not up to this. So, up to maybe this and then zeros. This is m minus 1. Okay. So, length n, length m, and n not equal to m. I am taking m to be less than n, it could be the other way. Then if I convolve, what will be the duration of the output sequence? So, if first flip it as before H 0, H 1 dot 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 H n minus 1, very much like what I did last time, minus 1 all that, okay, and this side is 0. Then for n equal to 0, 0 shift, you have got this sample multiplying this sample, you get some value. So, at n equal to 0, there is an output, some output. N equal to minus 1 means you shift it to the left, and then if you multiply sample wise, you get nothing. So, 0. If you shift it further to the left, there is n minus 2 minus 3, as I told last time, there is no overlap. So, you continue to get 0. This is n x is now. If you shift it to the right by 1, that is n equal to small n equal to 1, then H 0 comes below this x 1, H 1 comes below x 0, they multiply add, you get some value, and you shift it further to the right, 3 samples will come below 3 samples here, sample wise multiply add, you get some value, dot 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 dot. Finally, a stage will come when H 0, that is H 0 is the leader, followed by this, this guy is moving to this side as I keep shifting to the right by n equal to 1, then n equal to dot dot dot. So, the stage will come when finally H 0 has come to some index, so that the last guy in this trail, I am doing linear convolution, mind you, just coincides with this guy, okay, because I am multiplying these two. So, these two are coinciding, this is n minus 1. This is not n minus 1, sorry, this was m minus 1, so m minus 1. Okay, this is minus, I am sorry, this is m minus 1, so this is minus m minus 1. Okay. Earlier I took both up same length, and so it was 0 to capital N minus 1. So, it was going to minus of bracket n minus 1, but now since it is capital N minus 1, it is going to minus m minus 1. So, there is a mistake I corrected, all right. So, now My question is, I am giving shift 1 n equal to 1, small n equal to 1 bit to the right, small n equal to 2, another bit to the right, and dot 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 dot, and I keep getting some samples from this sequence, some samples from here, they are overlapping, multiply them, and you get output. And if this happens, so H0 is moving, H1 is moving, they are all moving to this side. Finally, a stage will come when H0 has moved to such, from 0 it has gone to this index, such that the last guy is here at n minus 1th point. So, these two are coinciding. Till that time, I will get non-zero output. After that, if I further shift it to the right, all output will be 0 and it will continue to be 0. So, what will be that case? By how much shift? Now, if H0 comes here, that means this guy has come here, isn't it? H0 has moved there, H0 from here, it has moved here. Same amount of shift has been executed on this. So, this has come here. So, it took m minus 1 points and then another n minus 1 points, okay. M minus 1, another n minus 1, all right. M minus 1 shift brought here, then another. So, this much shift. So, this is equal to m plus n minus 2, all right. So, if your n was 1, H0 would have been here, n is 2, H0 is here at 2th point, if n is 3, H0 would have been here. So, now n is so much. So, this is this index n plus m minus 2, which means the length is from 0 to n plus n minus 2. So, length now, new length is total is this 0, because this is n plus m minus 2, 1, 2, 3 like that, and then 0, this you have to count also. So, if you count 0 and then 1, 2 up to this, total is n plus n minus 1. So, you see, but by convolution actually output sequence becomes wider. If you convolve to finite length sequences, length m and length n, their convolution widens the sequence. So, sequence spreads in time domain. Okay. Now, I want to carry out this convolution by using DFT, that is circular convolution, because DFT advantage is there are very fast algorithm to calculate DFT called FFT. You can use them and then calculate inverse DFT also by this fast algorithm. Therefore, to make use of the fast algorithms, I want to go by the DFT route, but the DFT route I only have circular convolution. That is, when I multiply the DFTs and take inverse DFT, I have the circular convolution. But circular convolution is not my goal is linear convolution, there is this one. Okay. How to get the linear convolution from that? So, we will do some manipulation there, but you understand one thing, final output after linear convolution is not of length n or not of length m, but is length n plus m minus 1. If you call it L, so it is length L. So, 0 to L minus 1, you can call it L minus 1, okay, this is L, all right. So, my output, I should have a provision for so many points in my output sequence, which means what I should do actually, I will make both the sequences same length of L. So, I will go and append zeros up to L minus 1 here. So, L minus 1, n minus 1. So, how many zeros? L minus n. L minus n is m minus 1. So, m minus 1 zeros. And here I will append zeros, so that I again go to the same point L minus 1. So, L minus 1, m minus 1. How many zeros? You subtract this from that, L minus m, which is equal to, if you, this is L, if you subtract m, this is actually n minus 1. So, here m minus 1 zeros, here n minus 1 zeros. This is called a zero pad, zero pad, zero pad. This technique is called zero padding. So, I made both the sequences of the same length L. So, 0 to L minus 1, where L is, in short, I am calling for m plus n minus 1, because that is the length of the final output that I have seen. After this linear convolution, final output is wider, its total length is n plus m minus 1, that is L. So, it goes from 0 to L minus 1, that many points. So, I want to make input and H, both them of the same, of that length only. So, additional points I plug, set as 0. So, here it was length n, but I want to make it, that is from 0 to n minus 1, but I want to go up to 0 to L minus 1. So, additional zeros will be L minus 1 minus this. So, L minus n, that many, and L minus n is, if you have to m minus 1. So, m minus 1 zeros here, by the same way n minus 1 zeros here. So, Now, what I will do next step, I will take DFT of this, but not n point and m point. I will take L point DFT, multiply the two and carry out inverse DFT, that is circular convolution between this sequence with the 0 pad and this sequence with the 0 pad. And that also will be length L, because I will take the L point inverse DFT and we will see that will turn out to be this. Even though I am carrying out circular convolution, the presence of zeros in these two will make sure then that additional term which was coming earlier, this additional term, this will turn out to be 0, you will be left with linear convolution because of additional inclusion of these zeros. So, I repeat again, I have added this 0 pad of length m, that is total, length m minus 1, so many zeros, here also 0 pad n minus 1. So, both the sequences are now same length L, that is 0 to L by L minus 1. I take L point DFT. What are DFTs? Xk, Hk, L point, and multiply and they take in L point inverse DFT. So, you get a L point sequence, that will be circular convolution by your definition between this extended sequence with 0 pad and this extended sequence with 0 pad. But that circular convolution, if you carry out by the graphical means, you will see that this additional term is becoming 0 because of that presence of 0 pad, and you will be left with linear convolution. So, by that process you will get the linear convolution. This is what we will verify now. So, we will go by the graphical method. Okay. So, I draw what we have here. Graphical method means one sequence I will hold as it is and call it a function of R. This is our graphical method. So, this is R and this is suppose your x 0, okay. Other sequence, first I write as function of R H0, H1, H2 dot H n minus 1. Then next step was to make it periodic. So, same block will keep repeating. So, now this will be repeating. So, H0 will come here. This was point number 1, 2, 0. This was n minus 1. This is n. Then again this H1. Then again this H2 dot. And this side also there is periodic repetition, right. So, at minus n you will have again another H0, then at minus H1 dot at minus 1, this is periodic, this thing will repeat. I mean, whatever you have at any point, if you jump to the right by capital N, you will get the same point. So, at minus n, minus capital N, you have H0. So, jump to the right by capital N, you are at 0th index, you get H0. Then again at nth index, you get H0 like that. So, H1, okay, and last one is minus 1, it will be same as what I had here, H n minus 1, this guy. If you jump by capital N, you are hitting this index, you get like this. This was step number 2. Next, if you want to find out convolution at any index n, what will you do? You will shift it to the right by n, okay, and then you see only within this block and do sample wise multiplication add, because any data from this side and that side will get zeros only from top. So, they do not contribute anything. So, we do not consider them. Okay. Now, this was the general graphical convolution. Now, what we have here, this is just to remember, but what we have here is, we know that there was a 0 pad. So, we went up to, this is not n, sorry, this is L minus 1. Okay, let me redraw it, because making corrections there might be clumsy. So, this was your, anyway, this was just to recap that graphical procedure again. So, this was x r it was up to n minus 1, and then I have got 0, 0, 0, 0. This 0 I left out that time up to this, okay, where L was n plus m minus 1. So, total m minus 1 zeros. This was situation. I hold it as it is. Next sequence, the other sequence has H 0, say H 1 dot 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 maybe here, and then 0, 0, 0, 0, 0, n minus 1. Okay. So, this is actually length L minus 1 both, and now you make it periodic. So, you will add periodic repetition of this. Okay. So, to the right again you will have H 0 at Lth point, then H 1 at L plus 1th point, dot 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 dot, and this side at minus L you have got H 0, then H 1 at minus L minus 1 dot dot dot, at minus 1 you have got H this guy. Now, it will be good if I minus L, okay, then you have got this 0 pad, this part is here, okay, periodic, this part, then after that followed by 0 pad. So, here also you have got 0 pad, this is that 0 pad, this is that 0 pad, I am thickening it, all right, this is a 0 pad. How many zeros? M minus, I am not writing the indices, you can easily calculate from minus 1 to whatever, okay, till that time you have got some data, okay, but after that 0 pad, same n minus 1 zeros. Okay, so, this and then this 0 pad, here also you will have after some time you will have a 0 pad, okay, within a block like that. This is the situation. Now, you have to find out convolution at an index n will be from 0, 1, dot 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 up to n minus 1. This is the business. So, I will be flipping it and then shifting. So, if I flip it, H 0 remains here, H 1 goes here, dot 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 up to then this 0 pad, this one how many? N minus 1, and from this side this 0 pad first comes. What is the length? N minus 1. So, you see 1 to n minus 1 and this total n minus 1. So, this directly fits below this data block, right, because this is 0th index and total n minus 1 zeros, that will from 1 to n minus 1, and then again you have the data. Data means after the 0 pad you had H n minus 1. So, this will be H, okay, this m minus 1, all right, the same guy he is here, na, because of periodicity. So, that will come to the right hand side, okay. This 0 pad has moved and then this will move. So, this will go here next. So, H m minus 1 dot 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 and from minus L. So, this is coming at L minus 1 and then Lth here H 0 is coming, but I will be multiplying termwise over this block 0 to L minus 1 to this 0 to L minus 1. Anybody outside is of no consequence, okay, because they do not contribute. So, what you have here, you see here how many data? 1 to m minus 1. Here what is the length of this 0 pad? M minus 1. So, this is directly below this. When you multiply these samples with this sample, you get 0. Similarly, here this data are over 1 to n minus 1, but here this is a 0 pad. Okay. The 0 index, then you have got a 0 pad of length capital N minus 1, and this data from 1 to n minus 1. So, this length also n minus 1. So, this data gets multiplied by this 0 pad, this data which is from 1 to m minus 1, say total length is m minus 1, they get multiplied by this 0 pad. All right. So, they do not contribute, you have got h 0 into x 0, like linear convolution. In linear convolution, you just flip the original sequence, do not shift, so h 0 and x 0 that only comes. Then n equal to 1. Next is you shift it to the right by 1 and again see within this block and multiply. That time h 0 will come below this, okay. H 0 will come below this, H 1 will come here, like linear convolution, H 0 below this, H 1 below this and other data. But 0 pad is moving. 0 pad from point 1 it has shifted to point 2. So, it is coming here, H m minus 1 next guy. Okay. Instead of H 1 at L minus 1th point I have got now H 2, because this is shifted to the right, it has gone. But this data, now you see if I multiply this and this like linear convolution, okay. H 0 into x 1, H 1 into x 0, this H 0 has shifted, H 1 has come in, these two are multiplied, you are getting the result. How about contribution from here? Here you see, you have got data, like this part of the data, this is already in, this part, this data. This is from 2 to n minus 1. So, this is multiplied by this 0 pad, this extra 0, okay. This is multiplying the first 0 here, because the 0 pad also has shifted. Earlier 0 pad was starting from 1, now it has gone to 2. So, instead of coming from between 1 to n minus 1, this is now got one point to the right. So, it will take care of this n minus 1, take care of this n minus 2 samples now, then this will be multiplied by 0 and one more, this will multiply 0 here, and remaining samples will be multiplied by zeros here. Okay. So, I will get the same result, and this way if you continue, okay, after some time what will happen? Let me take out a fresh page. After some time what will happen, that suppose I am shifting now. So, n equal to 0 case I have taken, n equal to 1 case. After some time, okay, now the whole chunk has come here, say H 0, H 1 and followed by this H m minus 1. So, how many m points? Okay. If m is less than m, they are meeting data from here, but this is followed by this 0 pad. Okay. 0 pad is of length n minus 1. So, this is direct, this 0 pad is directly going up to full 0 pad is going up to L minus 1, because I have got total length H 0 H 1 up to m minus 1. So, m capital M samples are already here, 0 pad was length n minus 1. So, total length is m plus n minus 1, that is L, which means from 0 to L minus 1, this is my entire 0 pad. Okay, just count H 0, I am considering the case where H 0 H 1 up to H m minus 1 has come, and then this is, before this I have got another 0 pad of length n minus 1. But if this be the case, total length is L, out of which capital M gone here, 0 1 up to m minus 1. So, m gone. So, L minus m, okay, L minus m is the remaining length, and L minus m is, what is L? L was m plus m minus 1. So, L minus m is n minus 1 and the 0 pad is length n minus 1. That means, the full 0 pad is up to this, that is 0 to L minus 1. If you see the length, if you see the duration, out of which, so total length is L, out of which m length gone here and n minus 1 here, all right. And now, if you do the sampleized multiplication, assuming suppose m less than n, H 0 will multiply some data here, because it is m minus 1, it is 0, at m minus 1 point H 0, at 0th point m minus 1. This will multiply some data, this will multiply some data, like that, you get some value, okay. And then this is 0, okay. Additional data, this m minus 1, this m minus 1 might be here, m minus 1. So, you will have this data getting multiplied by this data getting multiplied by this data, like that. Okay. But how about this data? They will get multiplied by the 0. So, they will not contribute anything. Okay. After that, this will shift further. Okay. But as it shifts further, this block moves, but from behind which comes is zeros. So, again they do not contribute anything. These samples from here, they will multiply those zeros. So, only like linear convolution, this block will keep shifting and it will multiply from whatever data you have on top, and you will get the result. Okay. So, this is shifting, this is preceded by zeros, succeeded by zeros. This I am in a situation where full block has come in m minus 1. So, it is taking the m minus 1th point, m is less than n, multiplying this data with this data, then next data with next, and all that. Okay. Here whatever data I have from n minus 1 to n minus 1, they are multiplied by this part of this 0 block, and remaining zeros here multiplied by whatever zeros I have here, they do not contribute anything. So, it is still in the linear convolution way. Now, next if I shift it further to the right, this is getting further to the right, but will this, so under linear convolution, suppose I just shift it to the right by 1. So, this guy would come to the next, this guy would come to the next, this guy would come to the next. H0 earlier was at m minus 1th point, it was multiplying the m minus 1th sample, now it will be multiplying the next sample, and so on and so forth. But this guy, will it be multiplying something? If it multiplies some non-zero value from here, then there is an error, because under linear convolution this block is moving to the right. Earlier it kept fully under this, now it is moving to the right. So, there should not be any overlap between this and this. Now, if I carry out the product, who is entering, if I shift it to the right by 1, 0 from here. So, that will be multiplying x 0. So, no contribution. If I shift further to the right by 1 more, another 0 comes in. So, they do not contribute anything. So, what contributes is this part, and the way it is moving is like linear convolution. Okay. You can verify this by some example. So, this is the way, this is called zero padding technique. This is the way to carry out linear convolution via circular convolution. This is one important result, mind you, this is called zero padding technique. There is one more result from this DFT which I would like to cover. We have seen earlier that suppose you have got a sequence xn, okay, 0 to n minus 1, and then if you have DFT, you will find out DFT all right. Then using this DFT you can write xn by the inverse relation. Here summed over k. And then I said if I allow in this formula, if I allow small n now to go beyond this range, go to the right, go to the left from minus infinity to infinity, then that will be a sequence which is nothing but periodic repetition of this. Okay. That is, then it will be, if you allow, then it will be like this. Continued. If in this formula, if you allow small n to vary from minus infinity to infinity, what will you get? You will get an infinitely long sequence, which is nothing but periodic repetition of this periodic. Now, I will just take an example because this is useful for me. Suppose I have a sequence which is having 1, then 0, 0, 0 up to n minus 1. Okay, first, and then again repeated 0, 0, 0, 0 from nth point, then again 2 nth point, another 1. So, this is 2 n minus 1, 0 8th, again this side is 0, 0, 0, at minus n you have got 1, dot, 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 dot. All right. This is given. Suppose I take only this part, finite length, call it x n, and call this as periodic x tilde n. So, I take this one chunk, this block only 1, and 0, 0, 0, 0 up to this n minus 1. What is capital Xk? Capital Xk is xn e to the power minus j 2 pi k n by this, where summed over n 0 to n minus 1. But you see this sequence has non-zero value only at n equal to 0. So, only x 0 is 1, all other x values are zeros, and when x 0, n is 0 and e to the power 0, that is 1. So, 1 into 1. So, x k is 1 for all k. Therefore, if I calculate x n by the inverse DFT, it will be 1 by n capital X k, but there is 1. So, put 1. So, 1 into something, that is something only, e to the power j 2 pi k n by n. Now, if I allow small n to be, if I in this formula, if I allow small n to go from minus infinity to infinity, what I will get? I will get periodic repetition of this, okay, which is nothing but this x tilde n. So, this then will become x tilde n, where n is from minus infinity to infinity, this formula, if you allow, right. So, original x tilde n, a sequence like this can be written like this. You put any value of n on this side also, you will get the same value if you go walk back here, say whatever you have, the same thing will have if you go capital N to the right, further capital N to the right, like that. Okay. This is called sampling function, okay, and I will use it in my subsequent discussions. Thank you very much.